Okay, so this is going to be part 2 of the Chapter 12 homework illustrations. All right, this is number 6 with your Chapter 12 homework. And so we're looking at the ARR for the sandbox toy. I went ahead and opened up the dialogs box. So we're going to focus on just the sandbox toy project. Notice that the investment is $1 million. It's a 5-year life, 0 salvage value. So I'm going to make a note up here using that calculation. Your depreciation expense, assuming straight line method, is $200,000 per year. All right. So to calculate your ARR, you need your accounting income. So what you do here is they give you $1,480,000. What you're going to do is you're going to average that out. So if you take the $1,480,000, divide that by 5, your average annual income, that would put you at $296,000. But remember, the calculation is you have to then subtract out that depreciation expense of $200,000. So that's going to give you $96,000. So that's where they're going to get that number right there. And then you just divide by the $1 million of the initial investment, gives you an accounting rate of return of 9.6%. So then they say if they change the residual value, of course, if you change the residual value, the depreciation expense would change. And so you would have to calculate the ARR again. So just to remind you, you'd have your cost, which is $1 million. You subtract out $200,000 as residual value. Again, divide that by 5. Your new depreciation using that scenario looks like that would be about $160,000. So that's the new depreciation expense. So to get the ARR, again, you still have that same 296 average. Now though, you're going to subtract out the 160,000 of the new depreciation expense. And then when you do that, you'll divide that by the $1 million. And then that's going to give you 13.6%. Notice under either scenario, whether it's 9.6% or 13.6%, they both exceed the required target rate of return of 8%. So both of these scenarios you would say is a good thing for the company. All right, so this is an NPV calculation, net present value. So we're going to be looking at the present value of cash inflows. So the table we're going to use in this problem, if you read the last part of the sentence, it says that we're going to be saving cash flows of $13,000, $20,000, and $25,000 over a 3-year period. Notice those are not equal cash flows, those are unequal. So we will not be using the annuity table, so we can forget those. So we will be using the present value table, which I went ahead and pulled up down here at the bottom. The interest rate, it looks like in this problem, is 14%. I'm going to write this up at the top. So 14% is our interest rate, and our time period is n is equal to 3. So we have to actually discount each of these future cash flows for year 1, 2, and 3 back to today using this table. So over here off to the side, here's how you do it. So the first year cash flow is $13,000. That's a year from today. You'd go to the column where it says 14%, and you see in this case, you can find the 0.877. That's where they got that table factor. Multiply that by 13,000. That's worth 11,401 in today's dollars. Same thing for the second year, 20,000, and you find this 0.769. That's right there. That's where they got that number. Again, multiply that by 20, gives you 15,380. And then year 3, you got the 0.675. That's where they got that number times 25,000. Add all those up. You just discounted the first 3 years of uneven cash flows to be worth today of $43,656. Notice the initial investment is a negative because that's a cash outflow. So the cash savings are positive. So positive 43,656 minus 45,5 gives you a negative NPV. Negative NPV is a bad deal. So this, of course, would say this is not a good deal for the company because it's negative. And so that's not a favorable investment. Just remember, for an investment to even be considered, the net present value always has to be greater than or equal to 0, which essentially means it has to be positive. All right, this is problem 8 on your chapter 12 homework. Again, ARR calculation. So remember, anytime you're doing accounting rate of return, you're going to have to deal with depreciation. So I clicked on this icon, and so just to kind of show you, it's uneven cash flows, but I went ahead and showed you the bullet list. Year 1 is 330, then you got 290, 330. You can see how it varies, but the total cash flows for the 10 years is 2,460,000. Notice that you're going to divide that by 10 to get an average cash flow of 246. Then you need to calculate the depreciation, which they're going to do that right here. There's no salvage value. So you basically just take the cost of the investment, which is 1,540,000, divide that by 10 years. So your depreciation expense is 154. At that point, you're going to subtract the average cash flow, which is 246, minus your depreciation, which is 154. That's going to be the numerator. That's going to give you $92,000. That's going to be the top part, and then you just simply divide by the investment, which is 1,540,000, gives you an accounting rate of return in this problem of, it looks like it's 5.97%. All right, so here's another net present value problem. You've got two different projects. So remember, with net present value, we don't need to worry about the future value table, so you don't have to worry about those. I'm just going to put a line through those. The only question is it going to be the annuity table or the lump sum table? And in this problem, it looks like it's going to be, for both of them, it's going to be the annuity, because project A says 7 annual cash inflows of 60, so that's going to be a constant. That's an annuity. It's the same amount. 12% is the interest rate on that one. Project B, it looks like it says 9 annual cash inflows of 72. So again, both of these, you're going to pull up the present value of annuity table, which I did right there. So to get, if you're just doing project A, which is right here, you would go to N is 12%, I is 12%, and in this case, it's a 7, looks like it's a 7-year life. So 7, there's the number you're going to use right there, looks like it's 4.564, so that's where they got that number. Multiply that by the 60, which is right there. That gives you cash inflows of 276,830. That's a positive. And then the initial investment, which is a negative because that's a cash outflow. So you net these together, the cash inflows are more than the initial investment of a cash outflow. That's going to be a positive 3,840. That's going to be your NPV. So that's actually better than 0. It's positive. So you're initially saying that's going to be okay. Project B, very similar, except in this one it says you're using 10%. So go to the 10% table, and this one's going to be for, it looks like it's 9. So that's going to be right down there. You can barely see it, but it's 5.759 is your table factor, times your cash flows of 72, gives you a positive cash inflows worth today of 414,648. Remember, your initial cash investment's a negative because it's a cash outflow. You net these and you want it to be positive, and it is. It's a positive 34,648. That's going to be your NPV. Both of these, notice both of these NPVs are positive, meaning they are greater than or equal to 0. Right now, of course, I would say project B initially looks like it has a lot more worth because it has a much higher net present value. Now, part B says, now calculate the maximum acceptable price to pay for each project. Well, that's just going to be whatever it's going to be equal to whatever your cash flows would be to make this be 0. So if you go back over here for project A, your net present value of cash inflows, which was 273,480, that's the maximum price you'd want to pay, because again, you don't want that NPV to go below 0. And the same for B, it's whatever that present value calculation is, which is 414,648, which you just did. You don't want to pay more than that, because if you do, that would give you a negative net present value. Alrighty, so this is number 10, the last one in your chapter 12 homework. This is going to be your, they call it your capital rationing. And so what we're looking at here is your profitability index. And let's see, what do we got here? It says, which investment should they pursue? I went ahead and opened up this dialog box, and they've already given you 3 different scenarios. You've got equipment A, B, and C. They've given you the net present value for each of these, so they already did the calculation. Now we just want to say, okay, which one would be the best? They're all positive, but if we only could choose one of them, we have to use this thing called a profitability index to compare profitability. So in this case, what you do is, for equipment A, you take the present value of cash inflows and divide by the investment of 1,425,000, you get 1.2. Remember, the initial investment, that's your initial cash outflow. Project B, you take your inflows, divide by the cash investment there, which is $1,875,000. Notice you get 1.04. And for C, same thing, present value of cash inflows of $2,180,000 divided by the investment of $1,744, which is 1.25. So the question is which one should you choose? And it's all about cost benefit. Remember, the initial investment represents what you have to pay up front, and then everything else is based on what you're going to get in return. Based on all that, it looks like C gives you the highest index of 1.25. Even though, if you're comparing, let's say, why is C better than A? Well, you're spending a lot more money, $1,744,000 versus $1,425,000. So that's bad, but there's a lot more return, $2,180,000 versus $1,710,000. That's why this gives you a slightly better option because of that. There's more cash inflows. That's why this return, this profitability index, is a little bit higher. You would want to say go with equipment C.